Today's Leetcode daily challenge, and the name of today's daily challenge is find all the anagrams in a string. So the problem states that given two strings S and P, return an array of all the started indices of P's anagrams in S. You may return the answer in other order. The question means that we have to find the starting indices of P's anagrams, all anagrams in S. What is anagram? An anagram is a word or a phrase formed by rearranging the letters of a different word or the phrase, typically using all the original letters exactly once. That means exactly once. That means a permutation. Okay. Anagram is nothing just a permutation. Just like of ABC, it can be BAC, it can be CBA, it can be BCA, and we have to find the position of anagram of P in S. Okay. Just like for ABC, it can be CBA as well as BSC. And we have to search the string and find its position, starting indices. Just like for CBA, which is the anagram, starting index is 0. And for BSC, which is also an anagram, the starting index is 6. Okay, so let's see the second example and we will understand the question right. Okay, let's take the second example. We are given an S string A, B, A, B. Okay, and P is A, B. So we have to find the starting indices of P in S. So its anagram is also BA. Okay. Then so I can think of in a brute force way where I will traverse up to its size from every index, just like from A I will traverse up to, from B I will traverse up to 2, for A I travels up to 2. So this will take us big O of n into m time. Okay, which will give us TLE in the case when n is 10 to the power 5 and then m is also 10 to the power 5. This will give us a big of n into m. That's a brute force, naive. So we can do that. So we have to think of some another way. So the better way to solve this problem is I am getting is a sliding window approach. That is using two pointers. Okay, this is just like the problem we solved yesterday. I will maintain a hash map for it. Okay, hash map will be of 26 letters. The key to solve this type of problems is that using the constraints of the given input, we can convert an n square problem into 26n into 26n. This type of problems are common in CP in which we can convert an n square problem into something like a pattern in 26n in case of alphabetical problems or in 30n in the case of bit manipulation problems or sometimes in pattern problems we can 100n. It's like using this we can easily convert an n square into n. That's what we have to do. Using a two-pointer approach, we can convert n square into 26n. So we will maintain a hash map for P, that is our anagram, and in our hash map, we will store a frequency of each hash map for each character. Like for A, it is 1, for B, it is 1, and then we will run a sliding window. We will run a sliding window of size of P, that is 2 or K, over the S and check at each constraint does the hash map at, and we will for each sliding window we will maintain a hash map. When our hash map of sliding window becomes equal to hash map of our string P, then we will insert the index into the result. For a result we will maintain a vector result. Okay, and when we set our hash map of sliding window becomes equal to hash map of string P, we will insert the starting indices of the sliding window and we will slide the window one by one. When we are sliding the window, we will decrement the previous one from the sliding from the map and increment the new one or insert the new one in the map. Okay, so we will make a sliding window using two pointers L and R. That's how we'll solve the problem. So let's So let's just code it. I hope you got the approach. So let's start coding it. So let's make a hash map for our anagram, in which we'll store the our anagram. Okay. So the let's write time complexity. Time complexity peak of n into n to naive to peak of 36 into n using sliding window plus hash map sliding window 2 pointers. And the time space complexity will be big O of 1 because only 26 plus 26 letters are used. Okay, and next let's make a sliding window and a hash map for our sliding window also. This is basically just like the previous problem we solved. And a result vector, and for enter I is equal to 0 to, and k is size of p. Okay, no. Okay, let's see the constants of the problem. So as I said, constants are pretty high. The thing I can do is that if k is less than n, I can just return empty, because there will no anagram possible in the string, obviously. Okay, okay. Let's maintain a check. Our R will be at position k after the making a window. Bool check. Here I'm just making a window. Window of size. Size of window will be k. Using the two pointers. L pointer indicates the starting position of the window, and R pointer indicates the ending position of the window. So where R minus L plus 1 is equal to k. Okay. So I am going to compare the two hash maps. I haven't solved this problem before. Okay. In one. Okay. Check window and our hash map 7 million square. And okay. Let's run the window over the string. It's not. It will not be zero. It will be a. Sorry, sorry. I did a mistake because you can see that's how we store in the array. It has 0 to 26. So using SKI key and removing that, removing the starting one. Okay, removing the starting one. Now what? Adding it. Adding adding a new element to our sliding window. Our sliding window hash map and removing the leftmost of our window. Okay, so we have done this too. Now we will increment R and also increment L, and I will check it. Check window, check, then we will check if all these will obviously L is, and we will return the result. Let's see if this works fine or not. Oh, this returns empty array. What I have done? Oh, oh, shit. Okay, now okay. The first case is running. Let's check for second one. Oh God, check for second one. Is it working or not? Okay, it's working. Let's check this. If this is working or not. Oh, this works fine. 82%. So okay. So that's today's LeetCode daily science problem. Thank you.